Hi there, Mr. Sutton bringing you another lesson on solids. In this one, we'll check out the surface area of prisms and cylinders. In general, the surface area of solids that have two bases. And we'll figure out how much material is needed for a soup can label. Before we get too far into this, we need to make a distinction between total surface area and just lateral surface area. The surface area, or total surface area, which we call SA for short, is the area of all the bases and faces. So for example, with this square pyramid, total surface area, we'd be talking about the area of the square base plus the lateral area of the four triangular faces. If we're just talking about lateral surface area, or LA for short, we just want the faces, no bases. So again, just the triangles here, not the square base. In general, if you don't see the word lateral, they're looking for total surface area. In this lesson, we're going to talk about surface area of prisms and cylinders. You might notice that there's a surface area formula or two on your MCAS formula sheet for rectangular prisms. But what about any prism, even if it's not a rectangular one, like this prism here? So we're going to talk about a general formula for surface area. So this prism here, we could have a net that looks like this. And just to kind of relate some of the measurements over here to here, we've got these two bases here, the areas of those two bases. This height right here corresponds to the height of one of these squares, or rectangles. And the distance of all of these here, well, that's just the perimeter of the base, the distance around the shape. So the general formula for surface area of a prism, if you have this perimeter, the height and the base is going to be, for lateral surface area, just the perimeter times the height. That's the area of all these lateral faces. Perimeter, distance around the shape, times the height. The surface area of the whole thing is going to be that lateral area, the pH, plus 2 times the area of one of these bases. Just to clarify, when we say base, we're talking about the two parallel faces. And the height, then, is the distance between the bases. This is important because sometimes these prisms are going to be lying on their sides, and you have to remember, height is distance between bases, not necessarily height from the bottom of the shape to the top. Let's do a problem involving a rectangular prism. So for this one, they want the lateral surface area of this prism. And they're telling us that the top and the bottom are the bases, just to help us with our calculations. Because if you only want the lateral area, you don't want the area of the bases. So we're going to use surface area, or LA rather, equals perimeter times height. So first we need to find the perimeter. Now, perimeter is perimeter around the bases. So if the top and the bottom are the bases, we need the perimeter from here to here to here to here. So that's 6 plus 7 plus 6 plus 7. 2 6s and 2 7s, that adds up to 12 and 14, 26. The height, again, is the distance between the bases. Since the top and the bottom are the bases, the distance between them here is 3. And then we just have to do 26 times 3, which comes out to 78. And units here, that'll be 78 square centimeters. For our next problem, we're going to find the surface area of this triangular prism. Now, on the last problem, again, MCAS does give you a formula sheet with surface area of a prism, a rectangular prism, not any other kind of prism. So for this one, we're really going to want to try to use this 2b plus pH formula. The alternative to using this formula is you could find the area of the 3 rectangles and the 2 triangles and add all of those 5 areas together. But let's try it this way. We're going to have to find the area of the triangles anyway, right? So what's the area of one of these triangles? In general, triangle area is just 1/2 base times height. So the height of these triangles is 8. The base of these triangles is this distance right here, which happens to be 6. So 1/2 of 6 times 8 is going to be 24. And then the perimeter of the base, that's going to be 8 plus 6 plus 10. That's the 3 sides. So that's going to be 24. The height, the distance between the triangular bases, that's 5. So we've got 2 times 24 plus 24 times 5. 48 plus 120 adds up to 168, and that's square miles. Apparently that's a very large shape. We'll do one more of these prisms. Pause the video and see if you can find the lateral area of this trapezoidal prism. All right, let's see how that went. So lateral area, again, that's just perimeter of the base times the distance between the bases, the height. The perimeter here is going to be, let's see here, we have 8 plus 3 plus, this is a 5, plus another 3 because this is an isosceles trapezoid. So we've got 8 plus 11, which is 19. For the height, that's the distance between the trapezoids now. That's 6. So perimeter times height, 6 times 19. Well, that's going to be 6 less than 6 times 20. So that'll be 114, and that's square yards. We're going to do a problem on cylinder surface area now, and we're going to use a real-life problem to do this. Let's say a soup company designs a wedding-sized soup can with the following dimensions: 4-inch radius, 12-inch height. No, that's not the exact dimensions of this monster here, but this is still pretty big. This is like a bucket of soup. So how much material do we need to make the label that goes on the side? And then how about the whole can itself? For the label, we're just talking about lateral surface area. Instead of saying lateral surface area equals perimeter times height, well, the perimeter here is just the circumference of a circle, 2 pi r, so we can just say 2 pi r times height. This is really just the perimeter here. Now, the perimeter, the radius, we've got 4 inches, we have a height of 12 inches, so let's plug all that in and see what this comes out to. I'm going to put this in my calculator just so I get a real measurement here. So plugging all that in, and by the way, I did second and this little button here to get the pi symbol for the exact value, or you could use 3.14. This gives us about 301.6. That'll be square inches. And now for the total surface area, we have the area of the two bases plus the lateral surface area. So the area of a circle, what's that again? Oh yeah, pi r squared. So 2 pi r squared, that's the two bases, plus this is again is our lateral surface area. Pause the video and take a moment to plug in the correct things for this. So hopefully you had 2 pi times 4 squared plus 2 pi times 4 times 12. You could just borrow your answer from up here for this second part of it, but I'm going to plug it in fresh. Calculator time again. So I've got all that plugged in now, and that's going to come out to 402.1 square inches. This concludes our lesson on the surface area of prisms and cylinders. Join us next time when we talk about surface area of pyramids and cones. Until then, this is Mr. Sutton signing off.